Now that we have roughed out the part, it's time to start with the finishing. But before we do that, we want to knock these 3 holes out. There's no tolerance on the holes. They're very simple. So we're just going to take a flat insert drill and drill straight through the part. We have 2 5/8 holes and 1 1-inch hole. Let's take the 5/8 drill, bring it into the process list, and select holes. Here, we'll go to hole feature, reset all to absolute, and the top of the hole is 0. And we know that the bottom of the hole is minus 1.250. So let's go through the bottom to clear for the radius of the insert. Since this is an insert drill, it's going to be feed in, wrap it out. Coolant is on, flood is on. We simply click on either a point or a circle. And when we click do it, we will get the hole. When you're drilling holes, you can either use points or circles, and it doesn't matter which diameter the circle is. Let's do the same thing with the 1-inch drill, but we're going to make one simple change. On the 1-inch drill, the top of the hole is at minus 0.250, and we're going to leave the R-plane above the part, and of course the bottom of the hole is at minus 280. We click here and click do it, and the holes are now roughed out. We can continue where we left off in the last segment by simply clicking run, and you'll see the 5/8 holes and the 1-inch holes are now complete. It's now time to run an end mill around the bottom step of the part, and we're going to use a 1/2-inch end mill. It's going to have 5 flutes and a 45-degree helix so that we can use high-speed machining and chip thinning technology. Let's go to contour, and if we were to consult with the volume mill toolpath, it would say that we need to run this at 5100 RPM, 30 inches a minute feed rate, entry, and 60 contour. We want an entry and an exit line radius so that cutter compensation gets turned on. Remember, if you forget to put the line in here, cutter compensation in your machine will not be turned on. We're not going to leave any stock. We're going to cut the outside of the part in one pass. The top of the toolpath is 0. The bottom of the toolpath is minus 1.28. And we can set our entry and exit clearance planes to 0.1 and 0.1. Retract, yes. Depth first, yes. Prefer subs, doesn't matter. Ramp down, no. Back and forth, no. Cutter radius comp on, yes. And when we turn on cutter radius comp on, we're going to show you what overlap looks like in just a moment. Now we simply click on the outside of the workpiece and we select the outside circle and click do it. We now have a toolpath that cuts the outside of the part to complete size. Let's go to OpSim and have a look at it. Let's slow the throttle down so that we can see this toolpath clearly. And as you can see, the part looks a little chunky. What can we do about that? We can go to OpSim, right-click, Settings, and change it from Custom to Accurate. Now that we have an accurate toolpath, when we run through this simulation, you'll see that the part doesn't look as chunky as it did with the fast setting for simulation. And there we go, we have it all roughed out, and you can see how smooth the finished cut looks. Now it's time to do the next step up, and that step is up 1/4 of an inch. This was minus 1.250, this is minus 1 inch. Let's change only one parameter here on the toolpath, and let's make this minus 1. Do we have a piece of geometry that we can use for this? The answer is yes. Let's flip these arcs back over with Control T. and Control T. And now let's select the outside shape and the outside circle with our depth set to -1 and click Do It. And you can see that we have a toolpath, but there's something wrong. Remember those red lines that we cut there, that we made there with the Modify Toggle Wall Air? Those are not suitable for contouring. So we're going to employ another trick. We're going to use the outside geometry that is, and we're going to change the stock to -0.125 and click Redo. And as you can see, we get one complete toolpath. We simply offset the toolpath by 1/8 of an inch, which was the step width. Now let's look at overlap. The reason that we put a radius lead in and a radius lead out with a line connecting them is that this is what turns on cutter comp, and this is what gives us a smooth entry to the part. We go all the way around the part and we have a smooth entry off the part. But right there where these two arcs meet, there will be a little witness mark left by the end mill. And in GibbsCAM, we have a one-button solution for that. Let's add an overlap of 50 thousandths and press Redo. And now, here's the entry point. We go all the way around. And then after we pass the entry point, we cut the witness mark off and leave the part. The two steps on the outside of the part are now complete. It's now time to cut the two bosses here on the top of the part. Let's go back to the drawing and look at those bosses. Those bosses are here. They're simply round and they have a diameter, and the diameter is 1 1/4. Do we have enough geometry to cut these bosses? The answer is yes, because we're going to employ the machining markers to allow us to do this. The depth of this step is -250. We will set the stock back to 0 because we want to cut them to size, and of course cutter radius comp is still on. While we generate this toolpath, let's look at this from top view to show how we're going to cut this with the machining markers. Remember, the machining markers allow us to cut inside the line, outside the line, or on the line. We definitely want to be on the outside of the line, and we want our start point to be here, and we want our end point to be here. But notice that the toolpath is on going all the way around this side of the part. What if we right click and select Single Feature Cut? Now you can see that the proposed toolpath only goes from here to here at a depth of -250. When we click Do It, you will see our toolpath just cut that part of the boss. If we want to go all the way around the boss, that's also a simple item. We have just finished cutting the outside of the part with operation number 7. And the step on the outside of the part with operation number 8. Now, this part of the boss has been removed, and we need to cut away this part of the boss. Let's change the Z depth to -0.250. And let's change our stock back to 0. Cutter comp is still on. We still have our overlap. And we're going to perform an interesting little trick with the machining markers. We're going to cut from here to here, because on the boss, that's the only amount of material that's left. We'll click on this circle, and we'll click on the outside circle, and we'll tell the end mill to start here and end here. Remember, white is start, black is end, and purple is the proposed toolpath. Well, that doesn't look exactly right. So let's change that. Right-click the black dot, select Single Feature Cut, and our proposed toolpath is now purple, And when we click Do It, you can see our toolpath leads in, cuts away the excess material on this right boss, and then leads out, giving us a smooth transition. We only need to go to the other side and do exactly the same thing. Here we want to start here with the white marker, and we want to end here with the black marker. And we definitely want to cut the outside of the circle. The proposed toolpath says, well, we're going this way. Right click and single feature cut. And you can see that when we press Do It, our proposed toolpath will become real. And we now have a lead in and a lead out on the boss. And the bosses are complete. Let's have a look at the complete OpSim. Or we could just finish right from here. Let's slow this down and press play. We cut away the top of the boss, and we cut away the top of the boss. All done. Now, this end mill that we chose has a small radius in the bottom corner. I changed the radius to 0, and here on these two toolpaths, right-click and redo selected ops. Now, when we run this toolpath again, we'll run it kind of fast. We'll watch the volume mill do its job. We'll watch the contours do their job. And you'll notice that the chamfer is gone from the bottom of the toolpath. Now, it is time for us to chamfer the top, and chamfer the bottom.